Okay, so we're going to look at all of the properties that was in that homework assignment today. Okay, we're going to go through them one by one and kind of get some practice, and we're going to kind of throw some things together where you have to use many properties all in one problem. Okay? All right, so you have the whole table in front of you, but I just want to kind of talk through piece by piece for you. So the first one, product of powers property. I don't care if you know what they're called as long as you know how to use them. Okay, there are no proofs in this class, so if you're thinking back to geometry and you had to know the names of everything, you don't have to in Algebra 2. Right? Yeah, you can cheer, it's okay. I know you guys probably hated proofs. Yeah, it's a different way of thinking for sure. All this is saying though is if you have the same base, so the big number at the bottom, your base number, if they're the same, they're like terms and you can put those together, you would keep whatever that base is and then you'd add your exponents together. Okay, so and it's kind of broken down over there. But just so you can have some like a number example in here, if I had like 4 squared times 4 to the 5th, okay, the base numbers match, right? So it's going to stay a 4. And then you add your exponents. 2 plus 5 is 7, so that's 4 to the 7th. Okay, so the base number stays the same. Add your exponents together. All right, power of a power. Normally when you see a number outside of a parenthesis, what do you usually do with that number? You multiply, right? You're normally like you would distribute that throughout your parenthesis. Same kind of idea, it multiplies, right? It just comes in and multiplies by that exponent. Exponents only go to other exponents though, right? They're kind of snooty, they don't like any other people's type, they just want exponents. So if I had like x squared to the 4th, right, when that distributes, it's going to distribute back into just that exponent. I'm going to give you x to the 8th. All right, next one on here. Similar to this one, it's just saying if you have more than one thing inside of here, it's going to go to all of them, right? It distributes to everything. So if I have x and then y squared, and I take that to the 5th. All right, one of the things we talk a lot about in here is we have a lot of unspoken numbers in math. You're going to learn mathematicians are very lazy. Very lazy. And I will teach you how to be lazy this semester, okay? If I can do less, I'm going to do less. It's a beautiful thing about math. So we have an unspoken number, though. What's the exponent on that x? There's nothing written there. It's what? It's a 1. Yeah. So it's there even though we don't write it. We assume it's there. So sometimes it's helpful to write those in until you get more comfortable so that when you go to distribute, you don't forget that there is an exponent there that you can take that to. So that's going to be 1 times 5 is 5. And then you have 2 times 5, which is a 10. So it does go to all the exponents, even those unspoken ones in there. Okay, negative exponent property. We use this property so often. How many of you have seen the negative exponent property before and used it? Any of you? Oh, wow. Okay, I'm surprised by that. Negative exponent, it moves the number. Okay, if you can keep that in your mind, we're good to go. Okay, it moves it. So if it's negative, like right now, it's over 1, right? It's on the top. So if it has a negative exponent, it's going to take that and it's going to move it to the bottom. If it's negative on the bottom, it's going to move it to the top. That's how we make them positive. Okay, so for example, if I had x squared and then y to the negative 3, right? I only need to move the negative ones. So the x squared, that's positive, you can stay there. But the y, that has a negative, it's going to move. Since right now technically it's on top, it's going to move to the bottom. So we're going to have x squared, which will stay. But then the y has to move to the bottom, and then it becomes a positive down there. So anytime you move it from one or the other, that's when it changes to a positive. If you'd move a positive, what would happen to it? It'd become negative, yeah. We don't want negative ones, so don't do that. All right, quotient of powers property. Up here, you had when it was being multiplied and you added. So down here, when it's a division problem, right, a fraction bar just means divide, then you subtract them. So if I had x to the 7th over x to the 4th, since it's division, the matching terms of x's would become x to the 7 minus 4 is 3. Okay, so we just subtract top minus bottom. And it's always the top one minus the bottom one. All right, so next one on here. Very similar to what we did up here where it distributes inside. Same thing, it's just telling you if there's a fraction, it goes to both the top and the bottom. It goes to everything inside. And then the last one, it's the zero product property. The zero property, anything to the 0 power equals 1. It doesn't equal a to the first. It's literally gone, and it's just 1. So Quinn, one name I actually know right now. If I want to make Quinn disappear, I can raise him to the first power. Poof, bye-bye Quinn. He's not Quinn to the first anymore. He's just gone, and there's just literally a number 1 standing there. Okay. It can be anything to the power of 0. It's gone, and literally a 1 is in its place. So kind of cool, though, right? Make people disappear. You want to be gone? I'm going to raise you to the first power, and bye-bye. He's gone. Okay? So that's important to remember. A lot of times students remember the 0, and they're like, yeah, it's a 1, and then they write a to the first. No. It's not Quinn to the first anymore. It's bye-bye Quinn. He's gone. There's literally just a 1 there. Okay? So that's how you make things or people disappear, right there.
Can you set me to the first, please?
No, and miss all of your lovely entertainment for the class. All right, so here we go. So, all right, so one of the things students struggle with is they're like, how do I know when I'm done, right? Like you're going through a problem, you're like, am I done? Like, can I stop now? Like, do I keep going? Like, they don't ever know when to stop. So here's how you know if it's simplified and you can be done. Okay, first thing, simplified expressions do not contain negative exponents. If it has a negative exponent, what do you do to get rid of it? You move it. If it's at the top and it's negative, move it to the bottom. If it's at the bottom and it's negative, move it up to the top. All right, so it does not contain negative exponents or 0 as an exponent. Because if it has 0 as an exponent, what happened to it? It's just a 1. Like literally, it is gone, and there's a 1 standing there. Right? Gone. Yes. Mm-hmm. If it's just a line. Oh, technically there's always a line, right? Like all of this right now is over 1. Okay, draw the line in. Okay. All right. Has exponents that are blank numbers. Not prime. What kind of numbers do we want for exponents? Do you want decimals? Yes, I know where you're going with that, but one problem is with that. She said whole. What are whole numbers? I do want them real, but I don't want decimals, right? I know where you're going with that. Whole includes 0. That's my problem. Oh, do you guys know all your terms for those? They're called natural numbers. Whole numbers, she's right, does not have decimals, does not have fractions. They're only positive, but whole numbers includes 0. I was thinking of it says a whole number, a hole in the ground looks like a 0, right? It's a circle. That's how I always remember that 0 was included in whole numbers. But natural numbers, if I would be like, start counting. Where did he naturally start counting from? 1. And what direction did you go? He went up. Did he count with decimals? Did he count with fractions? Naturally, that's how he started. Those are your natural numbers. Okay. One of these years, somebody's going to bite me in the butt. I'm going to ask them to count, and they're going to start counting all weird. And then I'm just going to throw that analogy right out the window. Right? See, that's why I try to. Well, I guess you're part of that lab too, aren't you? See, normally I try to avoid that. Nothing wrong with that. He was just saying that, maybe they might start with 0. You didn't, so you're good. You're good. All right. Has a number base with an exponent of blank. All right. Number base, meaning it's like 4 squared. If you had 4 squared, would you leave that? What would you write instead of 4 squared?
16.
You'd write 16, I would hope, right? What exponent is on 16 right now? A 1. So I want number bases that have an exponent of 1. Now, granted, if you have like 25 to the 75th power, do I really want you to write out all those numbers? No. Okay. But I mean, if you have 4 squared sitting there, I mean, that's 16. So go ahead and simplify those. And you have fractions that are, oh, how many should know this one? Starts with an S. Simplified, yes. Yes, if you do not simplify a fraction, wrong. Taking a point off. Okay, we have to simplify. All right, you ready to just jump in and try a bunch of these?
Sure.
Yes, let's do this. All right, so the first one, number 1. Take it back to where it started. If you have parentheses, what do you normally do first with that number outside? We distribute, right? We're going to multiply that in. Now, what are the exponents inside that parenthesis right now? Thank you. There's an exponent of 1 right there. Don't forget those unspoken ones. Okay, if you need to write them in, because a lot of times we forget. So when we distribute, it distributes to exponents. It's going to multiply to all those exponents. So I'm going to have a 2, and then 1 times 4 is 4. So I have 2 to the 4th. Then I'm going to take it to the x. 4 times 3 is 12. And I'm going to take it to the y. 4 times 2 is 8. So there's my first step. I went ahead and distributed. Once you distribute, the parentheses are gone. Am I good there, or is there anything else I can do? What do you think? Yeah, what's 2 to the 4th? Good. So I have 16, x to the 12th, and y to the 8th. All right, if I went through my little checklist of what we just filled out up there, you know, I have number bases with an exponent of 1. I'm looking at, I have no like terms left over. I don't have any fractions, like no negative exponents. I'm good to go. All right, what about number 2? What would you do first, Quinn?
Same with -2 instead of,
Good, yeah. It's set up very similar to this one. There's negative exponents sitting there, but it's okay. Like, we're not ready to like call it quits yet, so let's just kind of deal with them. Again, you have that unspoken 1 right there. So when we distribute, it's going to go to the 1, the -3, and the 4. All right, so we have 5. -2 times 1 is -2. All right, then we're going to take it to the a. -2 times -3. Oh, that's a positive 6. 2 negatives, when they multiply, make a positive. 2 times 3 is 6. And then we take it to the b's. -2 times 4 is -8. All right, so there's step 1. I know there's more to be done, but let's kind of go one step at a time. All right, what's my next problem looking at that? Yeah.
It's for solving the exponent that's hanging off the 5 by putting a 1 over it and doing 5 to the 2nd power as the denominator.
Okay. You actually gave me 2 steps all in one thing. You're not wrong, but you did 2 steps actually. So the next thing I'm looking at is right now, I have negative exponents, right? Where do I put them? I'm going to have to move them to the bottom. Because technically right now they're on top, right? So the 5 moves down, and then it's a positive 2. The b has to move down, which will make it positive 8. What do I do with the a? He stays on top. Oh, yeah. Yeah. What you said wasn't wrong. Because then, yeah, so sometimes students try to do a whole lot at one time, and it kind of throws you. So take the time, rewrite it so that we've made them positive. They're on the bottom. And then 5 squared is 25. All right, so we have a to the 6th on top. We're going to have 25, b to the 8th on the bottom. Okay. No negative exponents. My fractions are good. I'm good. Questions so far? Yeah. That was your negative exponent property right there. You flip the base over the fraction bar and makes the exponent positive. Yep. All right, number 3. What about that one? What? That's it? I don't have to distribute or do anything? It's just 1. Anything to the 0 power is gone, and you just have a 1. We want a whole test full of those, right? Those are beautiful. It's just 1. Okay. Number 4. Oh, we got like 2 parentheses going on. What do you want to do first? Distribute. What are the exponents that I'm distributing to? 1, 3, 2. Yeah, that 7, it's not an exponent, but it has a 1 for its exponent. Okay, so we're going to distribute to all 3 of these. Something else is going to happen here that we need to talk about, though. So we have -7. 1 times -2 is -2. To my m, -2 times 3 is -6. We take it to the n, -2 times 2 is -4. Does it distribute forwards as well? No. I'm just going to bring that stuff down. M, N, 7. Yes.
The first thing that's worth noting is that your second power is not that, because a negative times a negative is the same. So you're just going to have 7 to the second power.
Kind of. Do we ever multiply the exponent by the base number? No, we don't. One of the things, let's keep going for a minute, and then I want to kind of touch on that -7. Okay? Let's keep going. Next thing, you have some options. I'm going to tell you what I would do, and if you want to do it a different way, that's fine, but this is what I would do. Some people hate negative exponents, and they want to move them right away and make them positive, and that's fine. I don't. I put like terms together first, right? Like I know those are alike. Because sometimes when you put your like terms together, sometimes it makes them positive again. Just kind of depends. Question? We'll talk about that in just a minute. Hold that thought. All right. The fact that I didn't put parentheses on the m end of the 7th over here is just because there's nothing being distributed to it, so they're really kind of just not necessary. If you had them still, it's not wrong. They're just not necessary. All right, what's the exponent on this m? 1. Okay, if I have like terms that are being multiplied, what do I do with their exponents? You add them. All right, so I have -6 plus 1 is -5. And then you have n's that are the same. So again, we'll add their exponents. -4 plus 7 is 3. Okay, so I put all that together, and I still have this weird -7 to the -2 that's throwing some of you. Hold that thought. I will talk about it. Okay, but at that step, all I did was put my like stuff together. Okay? My next step, once I put like stuff together, is probably to do what? I can't distribute it yet. Because to distribute it, there's only a 1 on the 7. So it really kind of turns back into the same thing. Yeah, what do you think? Yes. Yep. Before I can figure out the value of this, I need to make that exponent positive. Okay? So once I put all my like stuff together, then I move the negative ones to the bottom to make them positive. Okay? So what, or if anything, stays on top? End of the 3rd. Good. Because it was positive, he doesn't have to move. The negative exponents, they move to the bottom. Now, when I move the -7, it's still -7. The property says it changes the exponent to a positive exponent, not the big number. All right, and then the m is going to move down as well. Now it's m to the 5th. Now, can you tell me what negative 7 squared is? It is 49. Positive 49 or negative 49? Positive. All right, go ahead and grab your calculators. If you don't have one, go ahead and borrow one of mine, it's fine. But I want you to kind of take a look at something. All right, guys. So what I wanted you to look at is back to this whole reason this negative 7, I wrote it in parentheses, okay? In your calculator, type in for me negative 7 squared, just like that, like I wrote it in red. Hit the negative 7, exponent, square it, whatever you want, however you guys type that in. And tell me what you get. Negative 49. Right? Type in negative 7 in parentheses with the 2 on the outside of that parenthesis. The way I wrote it, ended up writing it down there, and tell me what you get. Positive 49. Now wait a minute. How are those different? That's exactly it. One's in parentheses and one isn't. Your calculator is being smarter than you want it to be. Okay, if you type in negative 7 squared, you mean negative 7 times negative 7, right? You want it to square the whole thing. Your calculator sees this as that's 7 squared, and then it multiplies that answer by a negative 1. Right? You're like, why would you do that? That's dumb. But the calculator recognizes exponents only go to whatever they are right next to. So in this top one, it is only right next to the 7. It's separating that negative as something else, like a different piece. Okay, down here you're saying, hey, stupid, the negative goes with the 7, please keep it with it. I want you to square the entire thing. And then it does what you actually want it to do. Okay, so rule of thumb, if you were unsure and you have a negative number, put it in parentheses. Okay, that's going to cover all your bases. You're going to be good to go. But that is why when I wrote this down, and you're like, wait a minute, where did those parentheses come from? It's because I had a negative number raised to an exponent. So for me, rule of thumb, negative number, throw that in parentheses, and I'm covered. Did I answer your question? If you just, technically, if you don't write it in your problem, then it's wrong. I probably wouldn't take off for that as long as you have the right answer, but if you want to be specific, you need them in your problem as well. It's going to help you remember to type them in your calculator too. Okay, so negative numbers, make sure they're in parentheses, otherwise your calculator is going to do the math wrong for you. Okay, number 5, negative 2x over y to the negative 3. Do I have anything that needs to be distributed? Nope. Do I have any like terms? Nope. Do I have any negative exponents? Yeah. So what needs to move? Just the y? Do I need to move the 2? I can have a negative number. I can't have a negative exponent. So the negative 2 is fine. Its exponent technically is 1. And I have an x. And since the y is on the bottom and negative, where is it going to go? It goes to the top and becomes y to the 3rd. And I am okay. Right? As long as you don't have any like terms left over, there's no more negative exponents. Numbers can be negative, exponents cannot. All right, number 6, the way it's written always throws students, right? It looks like you have the h and k are being multiplied by some weird fraction with an h in it, right? Just looks awkward. What if I rewrote this fraction bar? It looks just kind of curved and it looks more like that. Would it make more sense? Right? It's like, hey, this stuff is on the top and then that other part, technically it's on the bottom being divided. So if it helps you to rewrite that, you can. I can write it like that. Because, I mean, on the top, if I multiply by 1, does it change anything? No. So really, this is what that problem is saying. So don't be thrown when they write it kind of separate like that. It's just on the bottom. So do I have anything that needs to be distributed? Do I have any like terms? Yes. I have h's. What do I do with their exponents? You subtract them. All right, so what is 6 minus 4? That wasn't a trick question. All right, and then I still have the k to the fifth. Now, one thing students struggle with when they subtract like that is they're like, where does it go? Does it go on the top or does it go on the bottom? By default, it goes to the top. Okay? So when in doubt, when you subtract top minus bottom, it goes to the top. Now, granted, if it's negative, where would you end up moving it then? You'd move it to the bottom. But by default, it goes to the top. And then you can move it if you need to. Is there anything else I can do, or am I done? I am done. I am done.
Yeah,
Yep, I'm done.
I was gonna say the 1 is in there, and it's like, well, what times anything?
Right. Remember, lazy mathematician. If I don't have to write it, I ain't gonna write it. You guys will learn. I'm a very lazy mathematician. All right, number 7. Have you noticed kind of like my steps on every problem, what I've asked you? What have I always asked you first? Do I need to distribute? I sure do. Ooh, do you have any unspoken ones? How many? I have 3 of them. Yeah, that's 3 to the first, a to the first, and that's a 5 to the first on the bottom. Again, write them in if you're unsure, okay? That way you don't forget to distribute. Because this 3, since there's a fraction in there, it goes to everything, top and bottom. Okay, so we're going to take it to the top. So we have 1 times 3 is 3, so that's 3 to the third. Okay, take it to the A, 1 times 3 is 3. Take it to the C, 4 times 3 is 12. Right, it's also going to go to the bottom. So take it to the 5, 1 times 3 is 3. And it's going to go to the A, negative 6 times 3 is negative 18. So step 1, I just distributed to every single exponent. Okay? Next thing. What was the next thing I was always asking you? Like terms. Do you have any like terms? Yeah, you have your A's, right? All right, so what do I do with those exponents? You subtract them. Now, me being the lazy mathematician that I am, are you guys okay if I write what 3 to the third is in my next step right here? While I do that? What is 3 to the third? Thank you for not saying 9. It is 27. Right, because that means 3 times 3 times 3. All right, and then you said the A's, right? I subtract. So what's 3 minus negative 18? It's 21. Be careful, because it's 3 minus negative 18. What happens when you have that double symbol there? That becomes positive. So it's really just 21. And by default, it goes to the top. And then I have the C to the 12th. And on the bottom, what's 5 to the third? It's 125. Do I still have this A down here? No, I put that together with that one. I got that. Okay. So I took care of all my like terms. I distributed like terms. Do I have any negative exponents? Nothing to move. Can I simplify 27 over 125? If you're unsure, is there a way to check it in your calculator? Yeah, if you just type in 27, hit the fraction button, 125, and hit equals, does it simplify? If you were using the graphing one, do you guys know how to put fractions in those? On the graphing calculator, we're going to hit the green alpha key, and then you're going to hit the y equals button. It's literally 2 buttons above it. Hit the green alpha, hit y equals, and then just hit enter. And it gives you a fraction that you can fill in. So check that, try it if you have the graphing one, 'cause that's always comes up. How do I put a fraction in this thing? So then I'm good. If you hit the green alpha and then y equals, it brings up the fraction menu. It's just where they put it. I don't know why. I know it's kind of weird. All right, number 8. That's another weird one, right? What should we do first on number 8? Distribute, right? It's always the first thing we do. If we have to, let's distribute. Okay, do I have any unspoken ones? Yes. I'm going to write that in so I don't forget it. So it distributes. So I have D, 1 times negative 1. It's negative 1. On the bottom, that's an E, right? That looks really weird up close. 6 times negative 1. It's negative 6. Where does that stuff go? The D to the 7th, E to the 3rd, where does that go? Yes. Yeah, it goes on top. And here you go, Corey, in case you don't come back. That's homework tonight. All right, yeah, this stuff right now, technically that's over 1, so it's on top. So if you don't want to kind of lose track of where it's at, go ahead and put it on top. So I distributed. I just put the extra stuff on there that I have. Now what? Simplify your like terms. Yeah, we got some like stuff going on. So the D's, what do I do with their exponents when they're on top being multiplied? You add them. So negative 1 plus 7. So I have D to the 6th. And then the E's, what do I do with their exponents? Subtract. So 3 minus negative 6 is 9. By default, when you do top minus bottom, they go to the top. Do I need to move anything else? Is there anything else to simplify? Nope, I am done. You doing all right? We're going to get into some like crazy ones. Like some of today aren't terrible. Tomorrow we're going to do an activity in class and some of them get a little crazy. All right. Number 9. What happens when I have 2 fractions? Should I panic? Oh, I knew that was going to come up. No. The only times you like cross multiply is when there's an equal sign in between your fractions. I know students want to like, oh, cross multiply, like that's like ingrained in your head, right? Now this just means technically this is just one big giant fraction. When you multiply fractions, you multiply across the top and you multiply across the bottom. You only cross multiply again when there's an equal sign in between them. We have some options here. Personally, guys, when you have stuff on top and you got stuff on bottom and like there's all kinds of stuff that needs to be simplified, I would simplify the top, simplify the bottom, and then simplify them together. Somebody like last semester, what did they say? Something about like making your sandwich, right? Like you need your 2 buns before you can eat your sandwich together. I don't know. I like weird ways to remember things, and that was something somebody last semester said. So let's clean up the top. Is there any like terms or anything up there? Yeah, we can put those y's together, right? So I have a 3, I have an x to the 5th, and when I put my y's together, what does that become? y squared, right? Because there's 1's there, and 1 plus 1 is 2. Now, why did I write the 3 first before the x to the 5th? We just typically write them first, right? If I wrote x to the 5th, 3, y squared, it's fine. It just looks weird, right? So usually we just write the numbers out in front. Okay, on the bottom, what do I do with the 15 and the 4? Because they're just numbers. You multiply them. 15 times 4? Do we know that? It is 60. And I have a y squared. Okay, so clean up the top. You clean up the bottom. Now your sandwich, right? How do we clean them up together? Yeah. What happens to those y's? Why are they gone? Yeah, they're going to cancel. All right, so our y's are going to cancel. All right, what about the 3 and the 60? Does that simplify? That's a fraction. If you have 3 over 60, does it simplify? What's it become? It becomes 1 over 20. And then I still have the x to the 5th on top. So guys, if you're someone who fractions don't come naturally to you and you kind of struggle with them, use the calculator, okay? We're at a point in your math career as a junior or senior in high school, I don't have time in class to stop and reteach you fractions. If you want me to, when we have other time, I will. But as far as in class goes, if you're not sure, just type it in as a fraction on your calculator, hit enter. It'll simplify it for you. Okay? So if you're ever unsure, you can always go back to that. All right, let me give you guys a few minutes. Try number 10 on your own.
Oh, that's fun.
All right, we got 2 to go, guys. Last 2 problems. All right, we're almost done. All right. Last 2, though, there's a lot going on. So that's all right. We got this. So number 11. First thing we want to do, distribute. All right, so all of this stuff I'm just going to rewrite just so I have it here. All right, so when I distribute, technically, where is all this stuff located right now? Is it top or bottom? The way it sits right now, it's on top. Okay? So remember, you have an unspoken 1 on that S. So let's distribute to the R. So 3 times -2 is -6. We'll go to the S. 1 times -2 is -2. To the T, -4 times -2, +8. Does anybody see anything that I have written in that problem that just should go away? Yeah, not just the 0, right? S to the 0 is 1. So like this whole entire piece just vanishes, right? We can just cross that off. Anything to the 0 power is like the best thing ever, right? It's gone. So technically it's a 1, but we don't have to write the 1. All right, next plan of attack should be to do what? Combine. All right, let's clean up the top. So on the top, I do have an r squared and an r to the -6. What do I do with their exponents? You add. So what is 2 plus -6?
-4, I know.
I don't know you guys yet. I'm very worried when you say things like that. All right, I have s to the -2. I have a t to the 8th on the bottom. I have a t to the 9th. All right, so I cleaned up the top. Really, there's nothing clean on the bottom. Can I clean that top and bottom together? Yes, I do have the t's here. All right, so I have a t to the 8th and a t to the 9th. What do I do with their exponents? Subtract. So 8 minus 9 is, by default, where do they go? They go to the top. So I have 2r to the -4, s to the -2, and t to the -1. Okay, next step. How do I get rid of the negative exponents? Move them to the bottom. What happens to the 2? It stays, right? Because technically its exponent is a 1, so it's positive. So 2 stays on top. Then we have r to the 4th, s squared, and t to the 1st, all on the bottom. Okay, so the big thing with exponents is go one step at a time. If you try to do too much in one step, that's where we make mistakes. All right, I'm going to give you about 2 or 3 minutes. Number 12 on your own. All right, last problem. What is the first thing that we do? We distribute. All right, so that goes to everything inside this parenthesis. So we're going to have a to the -8, b to the -14, c to the -12. On the bottom, you'll have a to the -6, b to the 2nd, and then c to the 6th. Double check your work versus mine, right? First step, that's what you should have had. Okay, from there, you have like terms. Nothing's alike on top, nothing's alike on bottom, but top, bottom, we can go ahead and simplify those. So with the a's, what do you do with your exponents? You subtract. So I have -8 minus -6 is what? It is -2. By default, they go to the top. All right, the b's, -14 minus 2. Good. And again, by default, go to the top. And then the c's, -12 minus 6. It's -18. By default, goes to the top. All right, so that's where I'm at. Look good? Some of you thought it looked great, and you stopped. There's negative exponents there. I can't have those. So where do they need to go? All of them go to the bottom? Okay. So they all go to the bottom, right? A squared b to the 16th, c to the 18th. What goes on top? Needs to be a 1. If you don't put anything, then we assume there is no top of the fraction. So that 1's kind of like a placeholder, pushing them all down to the bottom. All right, how are we feeling about exponent properties? All right, tomorrow we'll spend another day on this with an activity. You can get some practice. And then we're going to move right into the radicals from here. We're going to kind of switch gears a little bit, move into radicals. All right.